Hello everyone, this is Shravani More. Me along with my team members Ishan Arvekar and Mehul Sharma are students of Vidyalankar Polytechnic. We have created a project on inventory management system by using the platform Live SQL. So basically inventory management systems are used for several reasons like preventing stockouts, cost control, improve efficiency, forecasting and planning, enhance customer service and many more. Here we started with the creating tables. What are the tables? Tables are a way to organize data into rows and columns, make it easier to read, analyze and interpret information. Each row typically represents a single record or entry, while each column represents a specific attribute or characteristics of the data. Table helps to present information in structured and systematic manner, facilitating comparisons and reference. Here we created the tables named as the product table, supplier table, customer table, order table or order detail table. The product table is a database table that stored information about the product. It typically includes attributes such as product ID, name, price, stock quantity, and here we applied the primary key on the product ID. The next table is the supplier table. Here the attributes are supplier ID, name, contact name, address, city, postal code, country, phone, email. Here the primary key is applied on the supplier ID. In customer table, the next table is customer tables where the attributes are customer ID, name, contact name, address, city, postal code, country, phone, email. Here we applied the primary key on the customer ID. Order tables, the attributes are order ID, customer ID, order date, status. The primary key is set to the order ID. In order details tables, the attributes are order detail ID, product ID, quantity, price, and the primary key is applied on the order detail ID.
Hello guys, I am Mehul Sharma and I'll continue from where my co-member Shravani left. As she already told, why do we create tables in SQL? Now it's my job to explain how did we insert rows in those tables. In our project, we inserted the values into the rows using procedure. Now you all must be wondering what is a procedure. Let me explain it to you. In a database context, a procedure refers to a set of SQL statements that perform a specific task or a series of tasks. These SQL statements are stored in the database server and can be executed multiple times without the need to rewrite the code each time. Procedures are often used to encapsulate business logic or frequently performed operations within the database. The syntax for creating a procedure is create procedure, procedure name. Then in round brackets, we write the parameters along with their data types. Then we close it using a closing bracket. As begin. After begin, we add the statements that we need the code to execute. After we have written all the SQL statements, we end the procedure using a end keyword along with a semicolon. Now, for our projects, we have created multiple tables. So in all the tables, we have inserted the values using procedure. For the first table, we have created a procedure named product_pro along with the attributes of that table. In the first table, that is the products table, we have inserted 30 values. That is, we have inserted 30 rows. In the second table, that is the supplier table, we have inserted 20 rows. As for our third table, that is the customers table, we have inserted 20 rows. For our fourth table, that is the orders table, we have inserted 20 rows as well. And for the order details table, we have inserted 20 rows as well using procedure. After we have inserted rows in our tables, we should start with some database operations. Let us start with sequence. Now what is a sequence? In the context of databases, a sequence is an object that generates a sequence of unique numeric values according to a defined pattern. Sequences are often used to generate unique primary key values for tables in a database. Let us know some key points about sequences. Sequences are used for sequential generation. That is, sequences generate numeric values in a sequential order according to a defined increment or pattern. Unique values. Each value generated by a sequence is unique within the database. Then independent of transactions. Sequences are usually independent of transactions. This means that even if a transaction is rolled back, the next value from the sequence will not be affected. This is particularly useful for generating primary key values, ensuring that each new row inserted into a table has a unique identifier. Concurrency. Sequences are designed to handle concurrent access by multiple sessions or transactions. Each session or transaction that requests the next value from a sequence will receive a unique value without any conflicts. Definition. The definition of a sequence typically includes parameters such as the starting value, the increment value, the maximum value. It is optional. It is only used if it is applicable. And whether the sequence should cycle when it reaches its maximum value or stop generating values. The syntax for creating a sequence is create sequence, sequence name. Start with start value, increment by increment value, and maximum value or minimum value as per our requirement. Now for our project, we have created sequences for all the tables. For products table, we have created a sequence named SEQ underscore product underscore ID, which starts by 1 and increments by 1. We have done the same for all the tables, such as for suppliers table, we have created a sequence named SEQ underscore supplier underscore ID. For customers table, we have created a sequence called SEQ underscore customer underscore ID. For orders table, we have created a sequence named SEQ underscore order underscore ID. For order details table, we have created a sequence named SEQ underscore order underscore detail underscore ID. Now all the sequences that have been created starts by 1 and increments by 1. Here we have not mentioned any maximum value or minimum value. From here, I'll pass the baton to my co-member, Miss Isha Narvekar.
I would now like to thank Shravani More and Mehul Sharma for introducing a microproject based on inventory management system and for creating tables and inserting values using procedure. Now, me Isha Parag Narvekar would like to continue the further part. After creating the sequence, we have created another database object which is synonym. A synonym in SQL is an alternative name for a table, view, sequence, procedure, function, or package. The syntax for synonym is create or replace synonym name for object name. Here the synonym name can be given according to our will, whereas the object name is the name of the object for which the synonym is created. In our case, it is a table. Here we have created synonym for all the tables, that is customers table, orders table, products table, or the details table. Then, to add more enhancement to our database, we have created view. A view is a virtual table based on the result set of a SQL statement. It's essentially a saved SQL query that you can treat as if it were a table. The syntax for view is create view, view name as select column 1, column 2 and so on from table name. Here we have created view for the products table. Similarly, we can create view for other tables as well using the before mentioned syntax. Next, we have used joins to retrieve data from our table. Joins are used to combine rows for two or more tables based on related columns between them. Joins allow you to retrieve data from multiple tables in a single query, enabling you to access related data efficiently. There are several types of joins: inner join, left outer join, right outer join, full outer join. In our database, we have used inner join, left outer join, and right outer join. Then we have also used the pattern matching operators to retrieve data. Those are also called as the wild operators. It consists of percentage and underscore. Range operator is also used to retrieve data between a particular range. Further, we have made use of aggregate function. Aggregate functions are functions in SQL that perform a calculation on set of values and return a single value. They are often used with the group by clause to group this result set into groups based on one or more columns. Count, sum, average, min, max are the types of aggregate functions. At the end, we have put screenshots of our outputs for better understanding of the execution of our inventory management system. Thank you.